Hello, today we'll discuss the classification of signals, and there are 5 ways of classifying the signals. And these signals are the continuous time signal, discrete time signal. We have discussed the even and odd signals, and now third we'll discuss the periodic signal and non-periodic signals. So this is the third way of classifying the signals. Let us see about the periodic signal. A periodic a signal x of t is a function of time that satisfies the condition x of t is equal to x of t plus capital T for all t, then that signal is called periodic signal. Then it is called a periodic signal. And where this t is a positive constant, clearly if this condition is satisfied for t is equal to t0, if this condition is satisfied for t is equal to t0, then it is also satisfied for t is equal to 2 t naught, 3 t naught, 4 t naught, and so on. Okay, the smaller value of the t is called the fundamental period of the x of t. Okay, the smaller value of t in the above equation is called fundamental period of x of t. Okay, so the reciprocal of this fundamental period is nothing but the fundamental frequency. So this is called as the fundamental frequency, and this is a fundamental period. And this frequency is, as you know, it is expressed or it is measured in hertz or the cycles per second, and therefore the angular frequency omega is the angular frequency. It is measured in hertz. Frequency is measured in hertz or cycles per second. Angular frequency is measured in radian per second. Therefore, it is defined as omega is equal to 2 phi f. And therefore, if you find substitute the value of fundamental frequency here, then it will be 2 pi by t. Okay. And any signal x of t for which no value of t satisfies the equation x of t is equal to x of t plus t, then it is called a periodic or non-periodic signal. Let us consider one signal. The signal is given like this. This is x of t, this is 1, this is minus 1, and therefore we have this is a square wave with amplitude a is equal to 1, and the period is, this is 0.2, this is 0.4, this is 0.6. So here the amplitude is here, one, and the period is here 0.2 seconds. Amplitude is 1 and period of this is a 0.2 second. This is an example of periodic signal because it is repeating after certain period. So this is one period. So after one period, the signal is also repeating. That's why it is called as the periodic signals. And the non-periodic signal, the example is suppose like this. This is amplitude of A, x of t, it is 0. The total duration of this, it is t. And therefore, here the amplitude is A and duration or it is a t1. And this is a periodic signal, not repeating after some time. Let us take one example. Determine whether it is periodic or non-periodic and also find the fundamental period. So it is a x of t cos square 2 pi, determine whether it is periodic. If it is periodic, find its fundamental period. Find its fundamental period. So this is given x of t is equal to cos square 2 pi t, and this we can also write here 1 plus cos 2 pi t by 2. Therefore we can write here half into 1 plus cos 2 pi t. X of t we can write here, or we can also write this is the half plus half into cos of 2 pi t. So this is the DC value, and this is a periodic where omega naught is equal to this is the formula actually. Cos square theta is equal to 1 plus cos square theta is equal to 1 plus cos 2 theta by 2. So 2 theta, here theta is this 2 pi. So here it will be 4 pi. This will be the 4 pi. Here it is also 4 pi, 4 pi. Okay, so what is the omega naught here? Omega naught is equal to 4 pi, and therefore T naught is equal to 2 pi by omega naught. So this 2 pi by 4 pi, and this is a 0.5 second. So the fundamental period here is 0.4 second. Next is the number fourth is the deterministic signal and random signal. A deterministic signal is a signal about which there is no uncertainty with respect to its value at any time. With respect to its value at any time is called as the deterministic signal. So there is no uncertainty with respect to its value at any time. At any time, the value is mentioned, and that is called as the deterministic signal. So just we have seen the square wave, which is a periodic signal, and it is defined for all value of the time, and therefore this is a deterministic signal. Whereas the random signal is the signal about which there is uncertainty. A random signal a random signal is a signal about which there is uncertainty. Before it occurs. It is called as the random signal. And the noise signal is the very well example of the random signal. Example is the noise signal. So this is about the deterministic and random signal. And the last classification of the signal is the energy signal and power signal. Consider the electrical system. In electrical system, a signal may represent a voltage or current. In electrical system, signal may be voltage or current. In electrical system, the signal may be voltage or current. So let us consider voltage V of t, voltage across a resistor R. V of t is the voltage across the resistor R, and it is producing current, and it is producing current I of t in the circuit, and therefore the instantaneous power is developed in this resistor. P T is the instantaneous power developed in the resistor, which is defined by Vt square by R, or it is also defined by Pt is equal to R into I square T. This is equation A. So in both the cases, the power, instantaneous power Pt is proportional to the square of the amplitude of the signal. Here the signal may be voltage or the signal may be current. So in both the cases, the power is proportional to the square of the signals, square of the amplitude of the signals. And therefore, in this way, we can find the power. So the total energy of the continuous time signal, let us consider the continuous time signal. So total energy for the continuous time signal E is equal to limit t tends to infinity minus t by 2 to capital T by 2. This is x square of t into dt. And therefore, this we can write here minus infinity to infinity x square of t into dt. And power P is equal to limit t tends to infinity 1 by t 1 by t minus t by t to t by 2 x square of t into dt. And therefore, the power equation we can write t is equal to 1 by t minus t by 2 to t by t by 2 x square t into dt. So this is for the continuous time signal. For the discrete time signal, for discrete time signal, for discrete time signal x of n, the energy is given summation over n equal to minus infinity to infinity x square of n, and power it is given limit n tends to infinity 1 over 2n summation over n equal to minus n to n, and this is x square of n. So here the average power is in periodic signal is x of n with the fundamental period n. So this is all about the classification of the signals. So we have discussed that there are 5 types of the signal. First is the continuous and discrete time signal. Second is the even and odd signal. Third is the periodic and non-periodic signal. Fourth is the deterministic and random signal. And fifth is the power and energy signal. Thanks for watching the video.